Hey guys, welcome back. Today we're going to do a quick review. We got some clouds here we're going to learn about, but then we're going to move on to air masses and source regions, which will set us up over the next few days to learn all about weather fronts. All right, first, this is just a kind of a generalized view of clouds and the three most common types. And if you look at the picture up above, there's all different kinds of cloud shapes, and I'm sure you've all seen different cloud shapes and maybe imagine they were things. Cirrus clouds, these are the high ice crystal clouds. Often they can forecast for us some snow or rain in a few days. These clouds generally mean that a warm front's moving in from far away, but you don't know really what warm fronts are yet, so I'll hold off on that. Stratus clouds. Stratus clouds are much lower. They're flat, stratified, if you want to think about it that way. And they could forecast potential rain or snow real soon. Cumulus clouds, these are the puffy ones. Stay Puft Marshmallow Man clouds. And they forecast nice, stable, fair weather. And if you look on the far right, you'll see the cumulonimbus clouds. These are like cumulus clouds on steroids. And these clouds actually form at cold fronts, usually at cold fronts, where you get thunderstorms. They actually can go above the troposphere into the stratosphere, temporarily. And then a lot of these other clouds you see, like cirrocumulus, altocumulus, altostratus, stratocumulus. These clouds are at different elevations, which is why they have different names like cirro or alto or strato. And then they mix the words together, prefixes, to kind of describe the different shapes of the clouds. So altocumulus would be cumulus clouds that form at higher elevations than normal cumulus clouds, for example. And stratocumulus clouds, these are just like layered, lower leveled layered cumulus clouds that cover a lot of the sky. So you see how they kind of put the words together. If you see the word nimbus in a cloud, it means rain. Okay, moving on. Now, today's main lesson is on air masses and source regions. All right, first of all, air masses. What are these things? Well, they are masses of air. Pretty obvious, but they're huge. These are bodies of air that can be many times larger than the size of states in the United States, and they have similar temperature and moisture conditions throughout. And you can see in this picture here, there's many air masses, which we'll learn about, each one of them in time. Air masses are usually described by whether they are cold or warm and dry or humid. All right, some air masses that we will learn. Maritime polar. And keep this in mind that the little m and the big P is important. You can't be switching these around. It actually does matter, the size of the fonts here. Maritime polar air masses form over oceans, maritime, and are cool or cold because of the polar. Maritime tropical air masses form over oceans. That's the term maritime, and they're much warmer. So these are humid, warm air masses. Continental polar form over land masses, continents, and therefore they're much drier. They can't pick up the moisture, and they're cool. And continental tropical air masses, these are formed over continents also, so they're drier. And because the air is much warmer, there's the tropical sign. And last but not least, we have the continental Arctic. These form up near the North Pole, and they are much, much colder, and they are dry. And here's a whole bunch of the source regions, air masses and their source regions all at once. Source regions are simply the geographic area on Earth where air masses particularly form. And just think about it this way. Air could stabilize and sit over a particular area for a period of days, and it would pick up the moisture and temperature characteristics of that area. And then perhaps the jet stream and prevailing winds would move these air masses into new locations, and it would carry those characteristics of that air mass with it. So here we have our maritime polar, our continental polar. Continental polars typically form over places like Canada, a dry but cool or cold landmass. Maritime polars, like over the Pacific and the Atlantic, forming over oceans where it's cooler. and they carry cool, moist air with it. Cool, moist air with it. Your maritime tropicals are moist, because they form over oceans, warm air masses that carry that warm, moist air with them. In continental tropicals, this is a source region, a place like the southwest United States where it's dry and warm. And so when those things get moving over us, it brings, well, in New York State at least, pretty nice weather. So just remember source regions, geographic area on Earth where particular air masses form. Now, one thing you should be aware of, especially for us in New York State, the two most common air masses affecting our state are continental polar from Canada and the maritime tropicals from the Gulf of Mexico. And they kind of battle it out depending on what time of the year it's in, as those prevailing winds shift north or south that we've learned about in prior lessons. Okay, labeling some of these air masses. All right, let's start off with letter A. Letter A, why don't we pause the video here and you guys can try this out by yourself, and then we'll come back and we'll go over all the answers. Okay, we're back. So letter A, if you said maritime polar, you were correct. It's forming over water and it's north, so it's pretty cool. B, if you said continental polar, you're correct. Sometimes continental Arctic if you're far enough north, but that is over a land mass, so it's dry and it's cold up there. So polar or Arctic. Okay, C is also over the Atlantic Ocean, so it's maritime and it's polar because it's cold up there. D is over the southwest United States. You know, think Arizona, think New Mexico, West Texas, perhaps the Chihuahua Desert of northern Mexico. And that's continental tropical. It's over land, so it's dry air and it's warm. E, you probably already knew this, maritime tropical. It's over the oceans and it's warm down there off the coast of Mexico. F, maritime tropical, either the Gulf of Mexico or the Caribbean. And that's a pretty good lesson as far as what you need to know about the air masses in this course. Now, source regions, where are these things coming from? Letter A is coming from the North Pacific. You can think about that as a source region. B, Central or Arctic Canada regions. C, the North Atlantic Ocean. D, Southwest U.S., the desert areas of the U.S. E, South Pacific, or at least, you know, Southern Pacific for our terms. It's probably more equatorial Pacific. And F, the Gulf of Mexico or the Caribbean. All right, now, this will be the last slide for today because tomorrow we move into fronts. But fronts, remember, are the boundaries between two air masses. So we've learned about these air masses now, and where one air mass meets another, that's what they call a front. So you can see there's a front here. There will be a front right here. There actually is one. We'll learn about that. Here's a cold front and a warm front. And much more complicated setup, which is realistic, of fronts in the United States. That's a snapshot in time. And so you'll be learning about these symbols too tomorrow. And this kind of gets us into, you know, violent weather and cold fronts, warm fronts, occluded fronts, stationary fronts. And it's a lot to learn. So we'll start up fresh tomorrow with this lesson. Hope you'll learn a little bit about air masses and source regions.